So before I go ahead, I would like to briefly review what we learned from the last class. In the last class, let me see, where's the recording? Okay, sorry, we learned the stoichiometry. It tells us the quantitative study of reactants and product in a chemical reaction. Like the video I showed you. So if you add in soda to the vinegar, at a certain point, the reaction will stop when the vinegar are totally consumed up. So that also can be illustrated by this chemical equation. For example, from this equation, I can read one nitrogen molecules, because only one here, only can react with 3 hydrogen molecules, no more, no less. The ratio is fixed. And also tell us if you multiply these molecules by Avogadro number, you have moles. That means 1 mole of nitrogen also only can react with 3 moles of hydrogen and produce 2 moles of ammonia. So from mole, we know 1 mole of nitrogen is this gram because the molar mass of the nitrogen gas is 28. Yeah, you have 2 nitrogen here. 2 times 14, 28. Similarly, here we have 6. So that tells us 28 gram nitrogen only can react with 6 gram of hydrogen. Yeah, and to produce the 34 gram of the ammonia. So that knowledge allowed us to do many calculations. For example, if we know the gram of one reactant, and if another reactant is in excess, and then we can calculate how many mole of that reactant, and then from this mole to mole relationship, we can calculate how many mole of the product. From the mole of product times the molar mass of the product, then we can know how many gram of the product can be made. So let's do some practice. We did this before in the last class, so I just repeat what we learned. Give you a review. So the question is how many gram of the nitrogen are necessary to produce this gram of the product. So the strategy is from the gram of this product, we can calculate the mole of this product, right? Just divide this one by the molar mass, how many moles. And from mole of this one, we can calculate how many moles of the nitrogen. Simply because there's some relationship here, 1 and 2. And from the mole of the nitrogen, we can calculate how many gram of nitrogen is needed. You see, this time we calculate from the product to reactants. Yeah. And so let's start from the gram of the product, and like I said, calculate how many mole of the product, and then mole to mole correlation can be found from this equation. 1 mole nitrogen react produce 2 mole of the ammonia. You see, so I put 1 and 2 here, and then from the mole of the nitrogen, of course, 1 mole nitrogen is equals to the 28 gram nitrogen. So use your calculator properly and cancel out over the line and below the line. The units and can be cancelled out. So finally, we have 6.17 gram of nitrogen. You see, it's very useful. Of course, they will ask you to calculate different kind of things in different problem-solving questions. You have to practice. I want to skip this one. We did it in the last class. So we did it 7 and 8 we also finished in the last class. So I skip this one. 2. So this one I think we also did it from my memory. Yeah, you can check the in-class practice and the key. So now from the new knowledge in this class is limiting reagent and percent yield percentage. Yeah. So limiting reagent was that like the video I showed you, the reagent used up first in a chemical reaction. It's called limiting reagent. Like the vinegar, it's totally consumed up first, and when you add more soda, no further reaction will happen. So another one is called the excess reagent. That means the reactants that is greater than necessary. Yeah, in other words, there will be some leftover. In order to understand that, I give you a simple examples. For example, let's prepare some lunch. Assume if we need 1 sandwich, 2 cookies, and 1 orange to prepare 1 lunch. Now, if we have 11 sandwich, 16 cookies, and 10 orange, how many lunch we can prepare? For me, I will say, okay, yeah, 1 lunch I need 2 cookies. I have 16 cookies. That means I can prepare 8 lunch. But after 8 lunch, I cannot prepare more lunch because that component is gone, cookies is gone. Even you have more sandwich but orange, but they left over. So this tell us, so the cookies here are limiting. So we can call it limiting reagent. And the sandwich and orange are in excess. So similarly, okay, I will not do acrylic, of course, it's online, but we can apply the same principle for this reaction. You see, 2NO will react with 1O2 to produce 2NO2, okay? So now tell us, okay, this same color, it's mean oxygen, O2, because they are identical. It's also indicated here. So from this picture, which one is limiting reagent? So the answer is the limiting reagent is NO, because now you have 6 NO, 1, 2, 3, 4, 5, 6, yeah. 6 NO, we only need 3 oxygen. Yeah, because 3 oxygen need 6, because 1 oxygen need 2 NO, 3 oxygen must need 6. It's proportional, right? Yeah. So if we only need 3 NO, 3 O2, sorry, but we have 6 O2, of course, O2 will be left over. The oxygen is in excess. The 3 will be left over. So that means this is limiting reagent. So NO is limiting reagent, okay.
Here we see 2 substances reacting with each other. Once all of the red molecules combine with blue molecules, the reaction comes to a halt, even though there are still blue molecules available to react. In this case, the red substance is referred to as the limiting reagent.
Yeah, this video also showed you the same story. When you have 2 reactants, one is limiting. So let's do some calculation using this limiting reagent concept. Do you remember in the previous calculation, we always tell you, okay, one component, one reactant is in excess. We said it's more than enough. So we can forget about that one. That means as long as you want, you have as many as you want, as much. So we only focus on one reactant before. But now, this new question, let's read how many grams of this one product can be made from 45 gram magnesium and 20 gram nitrogen. So the question is, we don't know which one will consume up. If we use this one to do calculation, for example, how do we know that nitrogen is still in excess? I mean, if before this one used up, I mean, nitrogen is already used up much earlier, that means the reaction will stop. Yeah, you will not use 45. You will not use up 45 grams. That means if you use this one to do a calculation, could be something is wrong. Similarly, like this, if I use 20 gram nitrogen to do calculation, I'm also not certain about if the magnesium will be consumed up first or not, which means the reaction will stop earlier. So what can we do is, in this case, we need to do two calculations. Our strategy to solve this problem is, first, let's assume the magnesium is limiting. The Mg is limiting. So if this is limiting, that means the nitrogen is more than enough. We can forget about it. That means as long as you want, you have more than a lot of nitrogen. So let's do one calculation, and then we will assume the nitrogen is limiting. Then we do another calculation. Then we will compare which calculation will produce less product. You will see what I mean. So if magnesium is a limiting reagent, then let's do calculation like I showed you before. So we have 25 gram magnesium, right? Can we calculate how many mole is this gram? We will use molar mass. 1 mole of the magnesium is equal to 24.3 gram magnesium. How do I know that? I can find this number from periodic table, right? The table below just underneath the element symbol. So that tell you the molar mass. So by doing that, gram cancel out. You know how many mole of the Mg. And then 3 mole of Mg, 3 come from here, will produce the 1 mole of this one. You see, right? So this is very important. You have to find this number properly from equation, not by imaginary. I mean, we cannot put some number randomly, or we cannot skip this step. So this tells you how many more of this one can be produced. Okay, by doing that, use your calculator, you get this value 0.4, 0.617. Sorry, and okay, so if magnesium is limiting, that amount produced. Similarly, we do calculation use nitrogen. Assume nitrogen is a limiting reagent. Very similar, the same method actually. So from the gram of nitrogen, calculate how many mole of the nitrogen, and this time you see 1 mole nitrogen produce 1 mole of the product, because here's 1, here's 1. Okay. So by doing that, you see the product is 0.7 now. Do you remember previous, if the magnesium is limiting, we only get 0.6. Now, if the nitrogen is limiting, we get 0.7. So from that two calculation, I can conclude the magnesium is limiting, simply because the magnesium produce less product. You see, it's a less product. That means when we produce 0.6172 mole of the product, the reactions already stopped because the magnesium is used up, stop. We cannot continue produce further product. Yeah, simply it's because Mg is gone. Okay, so nitrogen is in excess. So okay, anyway, you can simply memorize the limiting reagent is the one that produces a lower amount of product. This is all. Yeah. So now, since this is a limiting reagent, so this one I can use to calculate the final how many gram of the product. This I should use from the mole and times their molar mass. Yeah, 1 mole is equal to this gram. Now I have this mole. Of course, I time it. 1 mole produce this. Now I have these moles. So these moles will time this one. You get how many grams? You see, this is the final answer for this question. So we need to do 2 calculations from this. You can see. Okay, as I always said, I have the office hour from 1:30 to 2:30 Monday, Wednesday, and Friday. So if you have any concept is not clear to you, please join my Zoom virtual office hour. If you need another time, please let me know. And so now from this slide, we talk about the last part of this chapter, the percentage yield. Let's take a look at this equation. So the question 12 in your in-class practice. So if we start with 30 gram methanol and the excess of this PCl5, how much CH3Cl should we get? Since this PCl5 is in excess, so we can forget about it. That means there are a lot, but this one is limiting reagent. Yeah, the CH3OH is limiting, so we'll use that for calculation. How much of this one CH3Cl can get? Okay. So now we start from 35 grams of methanol, and again, first I want to calculate how many mole of that. This one divided by their molar mass. Yeah, you can divide it by the molar mass, or you can use this factor label method. 1 mole of the CH3OH is equals to this gram. Where this come from? Because I can calculate by their atomic mass. For example, carbon is about 12, and hydrogen is about 1 or 3 hydrogen, and then oxygen is 16 and hydrogen is 1. Just adding them together, you have 32. Okay, and then from the equation 2 of this one, methanol will produce this one, the 2 chloromethane. Yeah, so there are 2 to 2 relationship is. So, and then by here, I already know how many mole of the chloromethane. And then I use a molar mass of this CH3Cl. So by doing that, you see the units canceled out. So use our calculator properly. So we get a 55 gram CH3Cl. This calculation, this result is based on the calculation. So we give them a name. The theoretical yield of this CH3Cl is 55.15 grams. This is theoretical yield. By calculation, is ideally. However, in the real lab, for example, you did one lab, right? You separate some components. You will not get 100% product you want, because there are many reasons. Yeah, some reaction will be incomplete, and or some reactions that do not give this product, some byproduct. Sometimes we also can have some loss in transferring from one beaker to another, for example. For some reactants, in this case, for example, this reactant also can evaporate, into air, just disappear. Anyway, we don't have to care that detail. So what we know is sometimes we have less product, not sometimes, almost 100%, yeah, and then the theoretical calculated product. Yeah. Of course, sometimes your final result is higher than the theoretical yield because you have some water, like you did some experiments. That means some error, But anyway, let's assume if in reality, one student did these experiments, the real product is 42.65 grams. Then we can calculate that will be actual yield. We got actual yield. Yeah, compared with before. Theoretical yield is this one. The actual yield in the real experiments is 42. Then what is the percent yield of this product? So this can be calculated by the actual yield over the theoretical yield, 100%. So which means 42.65 over the 55%. So by doing this, you can see we can calculate the percent yield, which is very important because we want to know the percent yield for one reaction. Okay, I think we totally finished the chapter 3. I will stop recording.